We want to use these figures showing on your screen now to describe the simple concept of motion under gravity. This is a very interesting video. If you studied physics, you want to watch this video to the end because it is made for you. This video is interesting for anyone, so please stick to it, watch to the end, and you will benefit from it. First, what gave rise to these figures? Let us look at it properly. We are told that an object was projected vertically upwards from the ground with a velocity of 12 meters per second. Show that the velocity with which the object hits the ground on return equals 12 meters per second. Our target in this question is to show that the object that was thrown up with a velocity will also fall to the ground with the same velocity. That is theoretically correct, but we want to show it mathematically, so it is really interesting. Before we continue, we will make an assumption, a valid assumption, and this is the assumption. If you've watched this video to this point, please stay tuned. There is an interesting question at the end of this video for you to do. So you want to solve that problem to show your understanding of this concept. What is the assumption? When an object is thrown up, it is acted upon by gravity. Acceleration due to gravity acts on that object as it goes up at a constant value of approximately 10 meters per second squared. The same value of acceleration due to gravity acts on that object when it returns back, and because of that, the time it takes to get to the top is the same time it will take to get to the down or to the ground. That is why we can assume that since the object is acted upon by a constant acceleration due to gravity, the time taken for the upward motion equals that for the downward motion. Now, we know that there are two independent motions in this case. The first one is the upward motion, and the second one is the downward motion. Let us take them one after the other. First, let's look at the upward motion. This is the description of the upward motion. The object is thrown up with a velocity, initial velocity of u equals 12 meters per second. You will agree with me that the object will not go up forever. It means it will get to a point, it will stop, and then it starts falling down. What it means is that the upward motion begins from here and ends when it stops. And then the downward motion begins from the stop till it falls to the ground. These are the two motions. So for the upward motion, we are considering the motion from the ground to the top. And because the object stops at the top, it means for the upward motion, the final velocity is 0, v equals 0, while the initial velocity is 12, as we are told in the question. Now, let us recall the formula of motion under gravity that satisfies these parameters. And that formula is simply v equals u minus gt. Final velocity equals initial velocity minus acceleration due to gravity times the time it takes. You may be wondering why negative instead of positive. The object is moving upward, so it is acting against gravity. That is why the acceleration due to gravity is negative g. Now, what is our target here? We want to make t subject of the formula because we know from this assumption that the upward motion, the time for the upward motion is the same as the time for the downward motion. So if we make t subject of formula in the upward motion and do the same for the downward motion, we can then compare and know what v will become, the final velocity with which it hits the ground. From here, to make t subject of formula, we subtract u from both sides. So v minus u equals to negative gt. To obtain t, we divide both sides by negative g, so that t will be equals to v minus u all over negative g. Remember that v is 0. So if we put 0 here, it means t will be equal to 0 minus u all over minus g. And that is equal to minus u all over minus g. Negative can cancel negative, so that the time becomes u all over g. Now we've known the time. Let us consider the downward motion. This is how the downward motion looks like. The downward motion begins from the top to the bottom. Remember, at the top, the speed is 0. When it gets to the top, the speed is 0. For the downward motion, that 0 speed becomes the initial speed of the downward motion, which means u equals to 0. and the object starts falling down. We want to know the final velocity with which it falls down, and that final velocity must be equal to 12, the initial velocity of the motion. Now, we've put this together, we're going to record the same formula, but this time it becomes v equals to u plus gt, plus or positive because it is falling down in line with gravity, so the acceleration is positive. Now, if we make t subject to formula, we first of all subtract u from both sides, so v minus u equals to gt. To make t subject to formula, we divide both sides by g. Remember, the initial speed for the second motion is 0. So we have that t will be equals to v minus 0. And that gives us t to be equals to v all over g. So we know the t for the upward motion, we know the t for the downward motion. The same thing. On the next page, we have that for the upward motion, t is u all over g. For the downward motion, t is v all over g. Both are t's, the same t, so we equate them. Hence, we can say v all over g equals u all over g. Remember, we are looking for v. These g's are the same, so they can cancel out. And what you have is v equals u. And what is our u? 12. It therefore means that the final velocity with which the ball hits the ground is equal to 12 meters per second. This is how to mathematically show that a velocity, the velocity with which an object is thrown up, is the same velocity with which the object will fall down. You can see it is very interesting, it is simple, and you have enjoyed it. If you did, and you actually understood this, then here is a simple one for you to do. What is the maximum height attained by the object in its upward motion? While the object was thrown up, what is the maximum height it attained? If you get the answer, please put it in the comment section and I will be there waiting for you. Thank you very much for watching this video. Keep supporting Knowledge Base and see you in the next video. Bye.